Hello students, welcome back. As you all know, our one topic is left for chapter number 11, alcohols, phenols and ethers, and that I will discuss in this video. The topic is chemical reactions of ethers. This is the last topic. So here, as you can see, there are two types of chemical reactions that are shown by ethers 1 and 2. First is cleavage of C-O bond in ethers, and the second reaction is electrophilic substitution reaction. And in this reaction, as per your NCERT, three reactions are given. A is halogenation, then Friedel reaction, and then nitration. So I will discuss all these reactions one by one. Let us see our first reaction. Cleavage of C-O bond in ethers. Ethers are least reactive of the functional groups of all the functional groups. If we compare ethers with other functional groups, then these are the least reactive of the functional groups. Now, cleavage of C-O bond in ethers takes place under drastic conditions with excess of hydrogen halides. See, you need to remember these conditions. They are reactive under drastic conditions. It means the temperature should be very high and there should be excess of hydrogen halides. Okay, hydrogen halides means HX. We need to take this in excess. The reaction of dialkyl ether gives two alkyl halide molecules. See, these two reactions are given in your NCERT. See, I am writing them again. The first reaction given in NCERT under this topic is ROR, this is the ether, okay, plus HX, this is alkyl halide, okay. Now see, temperature is not mentioned, but you can write down that the temperature is 373 Kelvin here, okay. And what product we will get? We will get an alkyl halide plus alcohol, okay. The products are alkyl halide and the alcohol. See what is happening here. If you look carefully, then first of all, this is an example of symmetrical ether. This is what? Symmetrical ether. You know, when both the alkyl groups are same, then it is symmetrical ether. Now in this case, if we break the bond from here or here, it is the same thing. Okay, we will get the same product. Here if I write X and here if I write H, this will split. And one we will get as alkyl halide and one we will get the product as alcohol. Now the second reaction which is given in NCERT under this is ROH plus HX. See, in this case HX is present in excess. It is not written, but you can mention here. And if HX is present in excess, then what will happen? One product is RX. The other product, which is alcohol that is formed, will also give alkyl halide if HX is present in excess. And what we will get? H2 along with this. We will not get alcohol. This alcohol will also get converted into RX. So these are the two reactions that are given. Okay. Now this is R here. Now you can see both these reactions that we have discussed are pertaining to symmetrical ethers. But what happens if there are unsymmetrical ether? See, very important things I am going to discuss with you. Suppose if I take unsymmetrical ether like R, O, R dash. Okay, this is unsymmetrical ether plus again HX we are adding. Now what will happen? RX plus R dash OH we will get. Now how we will decide where the bond will break, whether it will break from here or it will break from here. Okay, and which alkyl part will form halide and which alkyl part will form alcohol. So For this reaction, you need to remember that there are two cases that are possible. Okay, so listen carefully. Two cases are possible. Two cases are possible. Now I am discussing the first case. You need to remember, if there is either 1 degree or 2 degree, 1 degree or 2 degree alkyl group present, then what will happen? SN2 mechanism will be followed and less sterically hindered alkyl group will form halide. Okay, less sterically hindered alkyl group will form halide. You need to remember this. See, I will discuss the examples also with you. And the second case, if any of the alkyl group is 3 degree, okay, if 3 degree alkyl group is present, then it will follow SN1 mechanism, okay, and the halide will go with tertiary or 3 degree part, okay, and that halide part will go with this 3 degree part, 3 degree alkyl group. Okay, now why this is the case? Again, the same reasoning is there in SN1. What is there? Formation of carbocation is there. Okay, and you know that tertiary carbocation is the most stable, and so the halide formed will be tertiary halide. Okay, so what you need to remember, there are only two possibilities. If one of the alkyl or both the alkyl groups are 1 degree, 2 degree, okay, or one is 1 degree and the other is 2 degree, the halide part will come from less sterically hindered alkyl group. And if any of the alkyl group is 3 degree, what you need to remember, that the halide part will go with 3 degree. Now in order to understand it well, let us see some examples also. Let me discuss the examples with you first. Suppose if we have this as our ether, see, if we have CH3O, CH2, CH3 plus what we have to do, HI. Okay, generally I is taken because as you all know, this is considered as a better leaving group. Now, from where we will split it so that the halide is formed, iodide is formed. Now, if you identify here, both are what? 1 degree. Okay, now where we will get the halide? As per rule, sterically less hindered part will form halide. Now, if you compare these two alkyl groups, then what you will see, this is less hindered or it is a smaller group. So what we will get, CH3I plus CH3 CH2OH as the alcohol. Okay, now why this is so? Because it will follow SN2 mechanism and there will be backside attack of the nucleophile and it will attack on that carbon atom which is less sterically hindered. So if we compare this or this will form the halide part. Okay, now let us see another example. This example is given in NCERT and this next example is also given in NCERT. Suppose I take this ether. In this, what is there? This is what? A tertiary group. Okay. Now, in this case, this comes under which condition? Second case or second condition. Okay, children. Now, here as you can see, this one is what? Tertiary alkyl group. So, it will split from here and it will follow SN1 mechanism and this will form the halide part. So, our product will be what? CH3, CH3, CH3. Here what will come? I will come and this CH3OH methanol will be formed. Okay, so you need to remember these two conditions, very important. Okay, now let us see our next part of reaction in this. See what we are taking in this, alkyl aryl ethers. So you can say this is the third part in cleavage of CO bond. Okay, first two parts we have discussed. One condition can be symmetrical ether, other condition can be unsymmetrical ether. This is the third condition. We are discussing about alkyl aryl ethers are cleaved at alkyl oxygen bond due to the more stability of aryl oxygen bond. Again the same thing. This bond, what is there? Partial double bond character is there. So it is difficult to separate this part. So cleavage will take place from here. And what will be formed? RX and phenol will be formed. So this also you need to remember. Okay. Now, if we compare the reactivity of hydrogen halides, Hi is most than HBr and HCl. You also know the reason behind this is greater bond length in this, and so it will break down easily. Now, the cleavage of ethers takes place with concentrated Hi or HBr at higher temperature. Temperature also you need to remember. Okay. So, this was your first type of reaction, cleavage of CO bond in ether. Okay. Now let's move on. The second category of reaction is electrophilic substitution reaction. Okay. Now electrophilic substitution reaction, what you need to remember is that the alkoxy group, this is known as OR. The alkoxy group is ortho and para directing and activates the aromatic ring towards electrophilic substitution. So you need to remember that the alkoxy group. What we are talking in this case, we are discussing about alkyl aryl ethers, which are this. Okay. And this group, which is known as alkoxy group, is activating. It activates the ring and directs the incoming group at ortho position or para position. Now why this is so? The answer behind this is plus R effect. Okay, due to resonance, all these structures are possible, and if you see, the electron density is maximum at ortho and para position. So substitution takes place here. Right, children? Now in this we will discuss three reactions. Okay, first is halogenation. Halogenation means halogen will be added. Okay. So phenylalkyl ethers undergo usual halogenation in the benzene ring. Example, anisole. You should remember that this OCH3 is known as anisole. Anisole undergoes bromination with bromine in ethanoic acid even in the absence of iron bromide catalyst. It is due to the activation of benzene ring by the methoxy group. This is an activating group. Okay. Para isomer is obtained in 90% yield. It means para isomer is the major product in this case. See, this is a reaction for this. Anisole, OCH3 is known as anisole. Okay. We are doing bromination. Two products, ortho and para, are possible, and if we compare, para is more or major product because of less steric hindrance. Okay. Now let us see the next example, which is Friedel-Crafts reaction. You have studied this reaction. Anisole undergoes Friedel-Crafts reaction, that is alkyl and acyl. Okay, Friedel-Crafts can be alkylation or acylation. Okay. Alkyl or acyl group are introduced at ortho and para position by reaction with, if we take alkyl halide, it will be alkylation, or acyl halide, it will be acylation. In the presence of, you know the reagent, anhydrous AlCl3 as a catalyst. Now let us see the reaction. See what is happening in the first reaction. This is anisole, and what we are doing, we are introducing CH3 group. So it will be alkylation reaction, and we will get 2-methoxytoluene and 4-methoxytoluene, and the para product will be major. And in the second case, we are doing acylation, because this introduction of COCH3 group is known as acylation. In this also we will get two products, ortho and para product, and the para product will be the major product. Okay, now let us discuss our last reaction. Okay, nitration reaction. Nitration means introduction of NO2 group. Anisole reacts with a mixture of Cong H2SO4 and HNO3 to yield a mixture of ortho and para anisole. What we have to do? We have to introduce NO2 group and ortho and para position in this. Okay, right? And again the para product will be the major product. You need to remember this. Okay, so these were the chemical reactions of ethers that I discussed with you today. See, this second part we have already studied, and what we need to remember that ortho and para products we will get in this case: halogenation, Friedel and nitration reaction. Now the first part I discussed, you need to remember it in three conditions. First is for symmetrical ethers, second for unsymmetrical ethers. Okay, where the two conditions were there, either 1 degree or 2 degree will be there, or 3 degree is there, then what will happen? We will get 3 degree in the halide part. And third were the conditions for alkyl aryl ethers. Okay, alkyl aryl ethers. So here we come to the end of the chapter. You should do all the NCERT questions in order to score well and understand all the topics well again. Okay children, thanks for watching the video.